so guys, this morning, what we need to do is we're going to look at an oblique cone, all right? But before we get to the oblique cone, let's have a look at where do we want to use these things, all right? If you remember correctly, I think in your last question paper you had one of these, but in oblique, all right? Where do we want to use this, all right? Engineer is developing a system of pipes, and he needs to go from a 100 millimeter pipe to a 50 millimeter diameter pipe. All right. So what is he going to do? Well, we need to develop a cone that is going to reduce itself from 100 to a 50 so that it can fit in here. So it fits like that. All right. But what happens now if somewhere along the line he cannot have this one exactly in line? All right. There's something in the way here. So we've got this 100 millimeter pipe stopping here, and then suddenly there's a component or something inside his way there, and he needs to bypass that thing. All right? Does he need to do a whole new system? No, he doesn't have to. All he needs to do is move that pipe to the one side, like we did here, and then what you're going to get is a cone that's going to look like this. Still 100 here, still a 50 there, but look now, it's angled. Right? Going to the one side there. Now it doesn't matter which angle it is. Remember, just there is a technique that we are going to follow to develop this one. All right. Let's quickly go back to the basics, just so that we can see a little bit of a difference. All right. If we have a normal cone, like that, with the apex exactly in the center, and if I have a top view of this thing, I'm just going to draw it in by hand here. Here's my apex exactly in the center, and I divide this one into the 12 segments. How are we going to know what is the true length and what isn't the true length? If you look from this side, can you see that the circumference of the circle here is right on the left, right on the right hand side? Okay, that's your furthest point. All right. So it's sitting there and it's sitting there. Apex is exactly in the middle, centered there, 90 degrees here. So there's a center line running through here. All right. So what you're going to get? You're going to get the true length on this side. You're going to get the true length on that side. So you can take a length right there, easy. All right. So if you need to cut off this thing either straight or at an angle, you must just realize that all of these lines are not exactly the same. Well, although they are the same length from the circumference to the apex, all of them you can go and measure them. They're exactly the same length. But because we're working with 2D flat surface, you must realize that this thing actually has a curve towards you. All right? But you only see a straight line there. So in other words, if you take a measurement from here, if you take those lines across and you connect them to your apex, if you take a measurement here and you take a measurement there, you're going to see, but they're not the same. Why? Because they are slanting. Okay. And because they are slanting, you can't use them as true lengths. So what you need to do is you have to make them true lengths. And that was pretty easy. All you need to do is transfer them horizontally to one of your true lengths there. And you can do your normal development. Have a starting point, use one of those segments as sides there, chop it there for you 12 times, so you can get the starting and ending point, connect them to your apex, and there it is, your development. All right? And then you can take these ones, and you can transfer them to those lines on that side, and you're going to get your development eventually, and it's going to look something like this. You agree? All right. This one I didn't cut it off at an angle. I cut it straight because where do we want to fit it? We want to fit it here. All right. And if we want to fit it in here, this is what it will look like. All right. That's what it will look like. So all you need to do, cut out your pattern here, put it on your piece of plate, transfer the markings, cut it out, roll it, bend it, whatever you need to do, spot weld it, and you're going to end up with something that looks like that. Right. Pretty straightforward. The base, and if that one was 100 millimeters at the bottom, this one 50 millimeters at the top, then you can go now and you can fit it exactly where it needs to fit here. All right. But this thing will not work on this side because there's angles involved. All right. So now that we know about this one, we recap on this one. Let's have a look at this one here. All right. The first thing that you need to see if you're going to draw this one is that we still have a center line. Okay. If you take this corner here of this side of the pipe through that side of the pipe and you extend it to the center line, and you take this side and that one, extend it to the center line, you are still going to find that you're going to have an apex there. Straightforward, no? So you're going to have a cone that's just lying at an angle here. And because it's lying at an angle here, we're going to call that one an oblique cone. All right, that's an oblique cone. All right, so let's quickly construct one and see the method of construction and what we are going to do to develop that one. All right, I'm just going to start off with a baseline here. I'm not taking any measurements, all right? I don't need to take any measurements now. I'm not going to use measurements. All right, I've got that one there, my baseline, and they will tell you, they can either give you some degrees here, or they can give you measurements from a center point to where you need to go with this one. I'm just going to use a 60 degree as a center line here, so that this thing is slanting at 60 degrees. Like that. All right. There has to be a base, and we know we need to find the size. And remember, we said, the engineer said that thing must be 100 millimeters in diameter, so we are going to get a radius of 50. And while you are here, instead of just marking it there, somewhere already, to save time, draw in your half circle here. Okay? It just saves a lot of time. You don't have to come back to it. And while you do that, someone get the center line in here so that you know where your center of this thing is. Right, so there we go. Now, they will tell you exactly where they want this one cut off, and where the apex should be. All right? So, for my purpose, I'm going to say the apex needs to be there. So, there's my apex. All right? So, what I'm going to do is I'm just going to connect this side to my apex, and that side to my apex. All right? And I know now exactly where I want this thing cut off because it needs to fit on a 50 millimeter pipe. Remember, I'm thumb sucking here now. No? I'm just taking a measurement here. So I say this one will need to be cut off there. There's my base. Right? And there is my sides. This is the part that I need to make so that it will fit in here. Okay. Right. So there it is. Now, remember, if you look at that one, I need to show you something else as well. And that is on this one. If I draw this one in here, at any angle, I've got my base sitting here, right? And I bring my apex down right in the center, there it is. I divide this thing still into 12, like you were taught, and I connect them all to my apex. All right? Those three there you can't see because they're behind it. Now if you look at the comparison between this one and this one, you will find that from the center apex here to the side there, if you measure these, they are all exactly the same size. All right? Because it's a centered cone, we call it a right cone. Right in the center is 90 degrees up. That point of the apex is exactly in the middle. Okay. Because this one is at an angle, you can take the measurement from here to this one, from here to that one, from here to that one, you're going to find 4 different sizes. They are not the same size. Right. But if you draw a front view of this one, we know that this point here is the furthest to the left. We know this one is the furthest to the right. Right through the center. We know that that one can be a true length, and we know that that one can be a true length. Right. But what about these ones that run inside here now? Here we could just transfer them vertically. If we cut it off, transfer the lines vertically to there to get a true length. But which one of the true lengths are you going to use? Because they're 2 different true lengths. You can't use two of them. You need one. All right. So that method is not going to work here. We have to find a new method. All right. All right. And this is how it's going to work. You still need to divide this half circle of yours. This one we're going to divide now into 6, because we're just doing 1/2. No? That one is there. It needs to be 60 degrees here. Right, there we go. I've just divided into 6. 1, 2, 3, 4, 5, 6. All right. So we know that this half here is now the same as the mirrored. It's a mirrored image of the half at the back side there. Now please note that there's a long side and there's a short side. All right. The rule for drawings is that we will start almost always with this short side of development. All right. So because this one of mine is slanting to the right and not to the left, I'm just going to do my numbering a little bit different than we used to. All right. So my numbering on this one, I'm going to start on this side. 1, 2, 3, 4, 5, 6, and 7. All right. We know 7, 6, 5, 4, 3, 2, 1 is at the back. Okay. Now, if I take these lines up to the base and connect them to my apex, it's not going to work. Why? Because they are not the same length. This one, that one, that one, that one, and that one is different lengths. So you cannot do that. It's not going to work. You need another method of making them true lengths. All right. And the only way that you're going to make them true lengths is by taking this apex vertically down. I'm going to use a red for this one. All right. Where it crosses my baseline here, I'm going to put that as my reference point. Okay. This is the point that I'm going to use to make these ones true lengths. Okay. How are we going to do that? Pretty easy. I'm going to take my compass, put it on point R. Notice please that point number 1 is already there. Notice that point number 7 is already there. I can't do anything with them. They are already true lengths. All right? But I can make point number 2 a true length. Select point number 2 there. Arc it so that it gets to the baseline. Can you see there? Go to the next one. Point number 3. There we go. Up to the baseline. Point number 4. Up to the baseline. Point number 5. Same thing. And point number 6. Point number 7 is already there. We don't have to worry about it. Ah, there it is. Transfer. I've got point number 1. There's number 2. There's number 3. Now we're going to ignore that one. Don't forget. Ignore that one. Then we've got point number 4, point number 5, point number 6, point number 7 is already there. All right. All I need to do is connect them to my apex. I'm not going to draw them right to my apex because it stops here, because it's cut off there. So I'm just going to, let me use a green pen again. Let me take them to the apex there. It was a construction line this. All right. 4, 5, and 6. There we go. 4, 5, and 6. Notice now. Now I've got a true length there. I've got a true length there. I've got a true length there. A true length. A true length. A true length. And a true length. Right. Now we can do the development. All right. Now the development for this one differs from the other one because now, instead of having one baseline and an apex to work with, you're actually going to have 7 baselines. 7 of them. All right. So what you need to do is, from your apex, take your first distance, which is number 1 here. Right, swing it across. Number 2, swing it across. Number 3, number 4. Don't forget number 4 is now not in the center, no? It's that one there. There's number 4, number 5. Let me just get my other hand in here. There's number 5. And 6. And 7. Right. So next time, I'm just going to make sure that I make it slightly smaller, that look there, right at the end of my compass. Right. My paper is a little bit too small there. It needs to go right around. So there's my 7 baselines. All right. What I'm going to do now, I need to have a starting point for this thing. I'm going to bring it as close as possible. I'm going to give it about a 10 millimeter gap here. Sometimes you will see that people use the side there, but because we are going to start with this one, I just need to give it a little gap here. All right. So, what's the trick here? We're going to make use of what we call a step-off method. All right. Step off. Right? What we can do is we can come to one of the chords here, because they must all the same size. Get your distance here with the compass, and we're going to start stepping off. We're going to start with point number 1 here, which is going to be right here. Okay? And we're going to step off of this one. All right. So there we go. Step off between 1 and 2. There we go, 2 and 3, 3 and 4, 4 and 5, 5 and 6, 6 and 7. Right? And then we're going to reverse. Right. 7 to 6 to 5 to 4 to 3 to 2. And what do you know? It fits to 1. All right. Can you see the difference now? Instead of having 1 baseline, you've got 7. All right? Now what we need to do is take each and every one of these points and we're going to connect them to my apex. There we go. Ja, julle leer mooi. Daar gaat hy. Apex. That one. That one. And you get the idea. It's important that we connect them to the apex because we're going to need them for the stop part here. Right. Right. Guys, please notice what I've done here is I'm just drawing the lines right to where they stop here. I'm not drawing them through there because otherwise I have to come back now and mark them again. I've already marked them. I just going to stop there so that I know I don't have to go any further. All right. So there we go. Let me just finish this half here. Remember, these are all construction lines now. My green is construction. Take that one there, this one here, this one there, and the last one is already in there. Okay. Apex, there's point 1, 2, 3, 4, 5, 6, 7, 6, 5, 4, 3, 2, 1. Completed. All right. All I need to do now is take my French curve. Okay. Now, I'm not going to take time with the French curve because it takes a bit of time. Remember, when you work with the French curve, you need to see 3, and then you draw in 1. Move it on. C3, draw in 1. C3, draw in 1. Right? That's the easiest method. All right. And remember, we've got 3 sizes of French curves that we can use. And the larger or the medium one will normally work pretty well with this. Right. Okay, there we are. Back online. All right. So, there's my bottom circumference sorted out. Okay. Now all I need to find out is where this thing is cut off here. That one is now pretty easy. Again, we've got 7 points there, isn't it? That's point number 1, 2, 3, 4, 5, 6, and 7. All right? So let's do the thing again, like we did previously. All right. I'm somewhere on the wrong side here, so I'm going to start with 7. There's 7. I'm going to go to 6, 5, 4, 3, 2, and 1. Sometimes, depending on the angle here, these lines can be pretty close. Okay? So you must pay special attention when you start with this thing. All right? We want to start with point number 1, where 1 and 1 is crossing here. There we go. 2. So we're just following the sequence here now. Can you see? We don't have to measure anything anymore. It's already given to you. You just have to follow the sequence here. 1 to 2, 2 to 3. Huh? Oh, starting here, no? There's 1, there's 2, 2 to 3, to 4, to 5, to 6, to 7, to 6, to 5, to 4, to 3, to 2, to 1. All right. French curve here. There I go. Draw it in with my French curve. Complete my outlines here. Complete my outlines here. And there's your development. Done and dusted. All right. It's important that you don't go and mix the two up. All right. Remember, if this thing is slanting, it has to be oblique. It's oblique, and because it's oblique, you need to make use of a step-off method. All right. All right. So there's the step-off method for the oblique cone. Done and dusted. Developed exactly like it should be. All right. You know what is a good practice? A good practice is taking a piece of hardboard. I've got some yellow stuff there. Put it underneath here. Take your any sharp point of your compass and punch these marks through. All right? Take it out, connect them again, draw it out, cut it out with the scissors, and then you make yourself something like this. Now you can see exactly what it looks like. If you bring it to your drawing, there it is. What I've done is I've done a drawing previously, just to show you guys the difference between the two. There's that one, there's that one. All right? This one, I punched these ones through. I made this one, there it is. It fits exactly there. And I made it from this one that I developed. And the other one, which is this one, that fits exactly there. I punched out this one, cut it out, and I made this one. There it is. Fitting there, fitting there. All right. So, just to sum it up quickly, so that we don't get confused, remember, with your normal cone, a right cone, I can, because these lines are all the same length, seen from the top, I can just transfer them to one side there and make them all true length, because this one and that one is exactly the same length. There's no difference. All right. On this side, I cannot do that because I've got two true lengths here. I've got this one here, I've got that one here. Which one are you going to use? You can't use any one of those because it's not going to work for you. All right. So you have to make all of them true lengths. You do them by bringing your apex down. All right. Remember, if you bring your apex down to your baseline, that's what's going to give you 90 degrees. That has to be perpendicular. All right. Use that for your compass as the center point of your compass, and then draw in your arcs here. One is already there, 2, 3, 4, 5, 6. Connect them to your apex. And then you can, here where they cross at the base, you can put your compass on A, swing them around, get your 7 lines there. All right? You can do the same with the top part here. There's going to be 1, 2, 3, 4, 5, 6, 7 lines there as well. All right? Get a starting point. And remember, now you don't have an ending point. You can't go take this one and do it on one line there. You have to start at point number 1 here. Well, in this case, for the base, it starts there. And then you're going to step off between 1 and 2, 2 and 3, 3 and 4, 4 and 4, 5, 5 and 6, 5 and 6 and 7. And then you do the reverse on that side. And where you end up here, that's your end part. And you can connect it to your apex. Get them all connected to your apex. And then you can draw in this one there as well. This one you don't have to measure. It's already there. You just follow the sequence. All right. You just follow the sequence. And if you get to the end, then you see, oh my goodness, the sequence doesn't work out. The chances are very, very good that you forgot to put one of these lines in there. So what I normally do is, as soon as I finish putting these lines and these lines in, draw them in, I quickly count them and make sure that I have 7 there. 1, 2, 3, 4, 5, 6, 7. All right. It's going to spare you a lot of extra work and grief if you count them before the time. This one, 1, 2, 3, 4, 5, 6, 7. So if I count 6, then I know I missed one somewhere, because remember, these things are very close. Some of these can be so close that they are almost exactly on the same line. There's like a half a millimeter difference between them. Okay? It depends on what scale they give you. It depends on what side, what slanting, anything. All right. Just to finish off lastly, you guys must also realize that not one of these cones is going to look exactly the same. All right? They can give you one where the apex is way past here. And you get your reference point there. All right? But what happens if this thing is just slightly off center? There's my center. What am I going to do now? Exactly the same. Exactly the same. All right? Point number 1 will still be there. You can swing point number 2, one side, 3, 4, 5, and 6, and you still got your true links. Okay? So you will not have a problem. It doesn't matter where this thing is at the end. If it's exactly in the center, then you know it's a right cone, and then we're not going to worry about this method. All right? But the moment it's off center, whether it is there, there, your point R is there, 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 or even there, it doesn't matter. Okay? Then you have to make all of them true links. But remember to number them here as well. If you don't number them on this side here, you're going to get confused, because you've got already a point number 4 for this one here. So number them, check them out, number them, so that you know you take the correct one when you swing it around. All right. Well, that is as far as we need to go now. So now we know that it's very possible to move pipes around and still line them up, making use of a cone. Okay. If there's any questions, you can ask your questions. But as far as this lesson is concerned, we have done now the cone that is oblique. All right. Thank you, guys.